heroes. The first to stretch the limit of man's expanse from one planet to another. Their names added to the list of great explorers of new worlds. In their footsteps, others will follow. What began as a trickle is free to rise into a deluge of humankind, sweeping over a once barren land and transforming it into a viable new world. When Baker and Zubrin presented Mars Direct to their bosses at Martin, they expected the worst. To their surprise, management was excited about it. They liked the fact that everything needed was relatively simple and near-term.
As time went on, Martin Marietta embraced Mars Direct as their creation and put Bob and I on an airplane to several NASA centers to present Mars Direct and try to build some momentum for it.
Baker and Zubrin flew to the Marshall Space Flight Center in Huntsville, Alabama. This had been one of the original design hubs for the Apollo moon landings, but recently many of the engineers had become demoralized by the failure of NASA's SEI program. Tag team style, Baker and Zubrin presented their alternative mission architecture. The response was thrilling. The old-school Apollo crowd embraced it. This was a plan that actually made sense and was within reach.
Baker and I gave a number of briefings. The first was at the Marshall Space Flight Center. Next was at Johnson. These people were incredibly excited.
Over the next few weeks, Zubrin and Baker were flown around the country, pitching to all branches of NASA. And everywhere they went, the response was electric. The plan was standing up to scrutiny, and groups all over NASA were converting to Mars Direct. Their tour culminated in a public presentation to the National Space Society. The crowd gave the two aerospace engineers a standing ovation. A week later, the story was in newspapers around the country. But a counterattack was beginning to form within NASA. The space station teams and many in the advanced propulsion groups were against the idea. Since Mars Direct didn't need their programs, they felt under threat. As quickly as doors opened for Zubrin and Baker, they began to close.
NASA didn't want to pursue a Mars mission at that time. They didn't want to be derailed by a bunch of Mars fanatics that thought that their idea of what NASA should do should overwhelm what NASA thought NASA should do.
What we did in Mars Direct was literally come up with the leanest solution, the one that involved the least spending on an assortment of technologies and infrastructural elements, including, for example, we made no use whatsoever of the International Space Station. And so people involved in all those programs were very upset because we were showing that you could go to Mars without their program being required. And they felt that we were de-justifying them.
The NASA administration rejected Mars Direct. The two engineers were outsiders again. But Zubrin remained determined.
Bob had grabbed hold of it, and I could see that it was his, and no matter what I did, he was going to do what he was going to do, and he was going to be a proponent for it and push it, and I really saw my role sort of evaporate. It's a little bit like being a dim planet next to a bright star around him in terms of his enthusiasm, and you really can't compete with that. All you can do is decide how you're going to deal with it.
By February 1991, Baker quit Martin to start his own firm. Zubrin battled on. For the next year and a half, Zubrin tried to get NASA to pay attention, giving speeches, writing papers, but Mars Direct's time seemed to have passed. But then in 1992, a new administration came into power at NASA, and Zubrin saw a second chance.
I was invited to brief Mike Griffin, who was the Associate Administrator for Space Exploration in charge of the whole Space Exploration Initiative. He immediately became a very strong supporter of Mars Direct.
But before the engineers at NASA would take another look at Mars Direct, they wanted Zubrin to prove that producing rocket fuel on Mars could work. They gave Martin Marietta a small budget to do an experiment. Zubrin and his team built a machine called the In Situ Propellant Plant. It could take carbon dioxide, the dominant gas in the Martian atmosphere, combine it with a little hydrogen, and produce a methane-oxygen fuel.
We did it in 3 months with a very small team. We built a plant that was 94% efficient, and no one who actually participated in that effort was actually a real chemical engineer. They were all aerospace engineers, like me, who were simply dabbling in chemistry in order to prove to NASA that 19th century chemical engineering really worked.
With the experiment a success, the administration had Zubrin give detailed briefings of the mission plan to the engineers at the Johnson Space Center. They liked it, but had some problems. Dave Weaver was the lead mission architect.
There were a number of things that we were concerned about with Bob Zubrin's mission. First of all, we thought his estimates of mass were probably too optimistic. Didn't have sufficient margins for a variety of things, not the least of which would be things like provisions for the crew, the amount of water that would be required. We thought his ascent vehicle was very large, which meant his power requirements, his propellant requirements were much larger than needed to be. His trip times out were too long, and that for very little effort you could get them shorter. The other problem was the size of his crew. He had a 4-person crew. I think virtually every study that's been done says that a 4-person crew for a 3-year type of mission is probably not realistic.
Weaver took Zubrin into his office, and the two men worked out compromise mission architecture. First, Weaver wanted 3 launches for every mission instead of 2. The first year, 3 ships would launch: a MAV, Mars Ascent Vehicle, an unoccupied HAB, and an ERV, Earth Return Vehicle. The HAB and MAV would land on the surface and begin producing fuel for the return flight and air for the crew. These craft would spend 2 solitary years on Mars, allowing NASA to test all of the systems before sending a human crew. Then, in the 3rd year, 3 more ships would launch, this time with the HAB occupied by astronauts. The other 2 ships are for a future mission, unless needed as a backup for this crew. Once on Mars, the team could also utilize the first HAB. Then, after a 1.5-year stay, the crew would climb aboard their small capsule and rendezvous with the return ship. This ship would carry them back home in a roomier environment than Zubrin's ERV. Zubrin called the plan Mars Semi-Direct. NASA called it the Design Reference Mission.
They had a larger crew than we had. They had bigger ships. They had more equipment. They had heavier equipment. So they had to do the mission in 3 launches instead of 2, but it was done with the same principles of Mars Direct.
The plan was subjected to the same cost analysis that tagged the 90-day report with a $450 billion price tag. The Design Reference Mission came back at a fraction of the cost, $55 billion. Spread out over 10 years, it could be done within NASA's existing budget. The plan made the cover of Newsweek. Here was a mission architecture that was affordable and could be done today with existing technology. But NASA's astronauts have not left low Earth orbit since.